Out for some of the work that we missed because of my 2 days that I was missing, in your case 1 day, Wednesday. And that basically takes us up to where we're going to start today. We're going to look at only testing single proportions A and B. So I've took the testing, hypothesis testing of 2 proportions out of this week's homework, and therefore it's not going to be in the test. So you only need to get A and B done for this coming week, and on Monday they're going to be a test. And I haven't even thought about what's going to be in the test yet, and I'm probably not going to be up to doing it today, but sometime on Saturday I will send you out an email telling you all about the test. But it's
not be nice and straightforward for all of us.
It'll be, well, I don't know how straightforward, I hope it is, but it will be very like all the other tests. It'll be just out of WebAssign and WebAssign questions, where you try and show me as much working as you can to get the extra credit part. So where shall I start? I guess I should move over to my screen that I've got and do basic and do this one. I'm going to do the shared screen thing because we need kind of both at the same time, and I don't want to come in and out because I'm not very good at doing that, and I end up closing all the good windows. So if you watch the video, you'll see that I've covered a lot of the stuff that goes on here. And I'll start at question 10 then.
The key.
Oh, I got the key on. Huh. Yeah, that's probably not a good idea, is it? Well, it's definitely a distraction. I think it was about question 10, thereabouts. Yes, there we go. So in the first question, suppose that a one-sided test had a p-value of 0.03. What would a two-sided test give you as a p-value?
The key is still on.
The key is still there.
I don't know how.
Will you stop fighting me, computer?
Maybe it just wants to give us the answers.
It's trying to give you the answer. And can you see that all you do is you double that number? So if you're wondering where the 06 came from, it's just double 0.3. No.
This is the A portion of the homework.
This is the B portion.
Oh, right? Okay.
So we're working on the B portion. I'm going to get that finished first, and then we'll go back and finish off the bits in A that we never covered. So that's kind of my goal. And so in question 11, the next one, in a previous example, we were given some data. I'm going to have to shrink this data down a little bit, maybe, so I can read it. One more. Gotcha. Can I shrink that a little bit, get some extra room? Maybe expand this. Just trying to tweak the real estate. Right. In a previous example, results were given for a survey of students in a stats class who measured the length of their right and left feet. And they found out that 108 of them out of 224, they were the same, which isn't a surprise, not to me at least. Assuming that the class is representative of college students, is there convincing evidence based on this data that the proportion of college students whose feet are the same length differs from 1/2? Okay, so the null hypothesis is that it's a half. And we're being asked to see if there's evidence that it differs from a half. Differs from a half is another way of saying it's not the same as a half, right? And I have to put that funny exclamation mark equals there, right?
Where did you get the half?
Let's see. Yeah.
Okay, thank you.
Now it says verify that the necessary conditions are met. So we are told that we can assume that the sample represents all college students, and that was up here somewhere. In addition, we can find NP0, and N is the sample size, which is what, 224? And P0 is a half. So if you do 224 times P0, you get a number that is bigger than 10. In fact, you get the number 112, I believe. So n p naught is 112. And n 1 minus p naught is also 112. Because it's the same sample size times 1 take away a half is still a half. Both quantities are at least less than 10. That's good. At least 10 means they're bigger than 10, I should say. So we have found that the necessary conditions are met. So that's how you fill that in. Now it then goes on and asks you to calculate a test statistic and a p-value and then a conclusion. So this is where this guy comes in. When you go over here and you hit salt and hit inferential statistics, make sure that you're on a one sample proportion. And in this story, they're going to be 108 out of a total of 224. So one sample proportion, 108 out of 224. Now this one is 0.5 and oh, exactly what we want, right? 0.5 and not equal to. So why 0.5? Because of this. Why not equal to? Because of that. Now, when I hit generate results, we have them over here. You see we've got the null and alternate. The guy that they're calling the statistic is actually the z-score. So I'm just copying that and pasting it in this box. And I'm doing it to 2 decimal places, so he becomes 53. And the p-value is not very significant at all. And to 4 decimal places, that 29 turns into a 30. Now, this p-value is greater than the standard significance level. The standard significance level in this book is an alpha of 0.05. So whenever you see that phrase standard significance level, it means this number is 0.05. So there is not enough evidence to conclude anything. The p-value there is huge, 0.59, right? Nothing to see here. Now, if that p-value was tiny, 0.0002, that kind of tiny, then wouldn't we say, yeah, there is enough evidence. It's in this case, is different from 0.5. Now, once you've got a template sorted out, you find a lot of these questions follow that same kind of theme. So hopefully you'll get into the swing of it. So the next one, a poll was released in the year 2000, found that 48%, so I'll better write that down because it might be important. 48% of 2,150 adults classified themselves as very happy from a list of choices. A journalist who's kind of pessimistic took advantage of this poll to write a headline. The poll finds that statistically fewer than half Americans are happy. Well, 48% is less than 50%, and that may or may not be true. So let's see what we've got. The null hypothesis is that it's 50%, and he's saying that there's evidence to prove that it's less than 50%. Are you happy about the choice of null and alternative? Now, when it asks you to do the conditions are met, don't we basically just need to find NP naught, which is half of this guy, which is 1,075. And this guy also happens to be 1,075. And both quantities are at least 10, so the conditions are met. Now, the last chunk of the questions, these guys here, we get from Sol. So I'm going to go over here and I'm going to put in the data that we have this time. And the data that we have, oops. Oh, and here's my problem. and I'm glad I wrote it down. We have in this sample 2,150 people, but they didn't tell me how many out of that 2,150. They didn't tell me the number, they told me the percentage. So I'm going to find 48% of 2,150. And that ends up being 1032. So do you see that in this particular question, didn't have to find that guy as a number, because that's the way SALT wants it to be given. We have a 0.5 thing, but in this case, we want to show or see if there's evidence that it's less than. So I've got one sample. How many out of the total? 0.5 less than. Hit generate results. And we are looking at a Z-score, which is the test statistic of this fella. And to two decimal places, that's 185. And a p-value, just this guy. And I want this to 4 decimal places. So 1, 2, 3, that stays as an 8. Now, this p-value, is it less than the standard significance level? Is this guy less than him? Agreed. So the p-value is less than this fella. So there is sufficient evidence. So what we can say here is, yeah, he's telling the truth, that there definitely is less than 50% said they were very happy. Would you also agree that the difference is quite minimal? It was only 2% difference. So in that sentence there, you could write down, yeah, it's statistically significant, but not that important, right? A couple of percent shy of 50% isn't a major, we're all suicidal, right? It just means it's not quite a half, but it's darn close. So that's the kind of sentence I would be putting in here. Okay, let's pause for a minute. Are you getting more comfortable with how to use SALT to do hypothesis tests? Right. You're given some information, right, to do a sample, and you're given a null hypothesis, an alternate, some part of the story in English, and then from there you move on. Eventually getting a Z-score, but more importantly, getting a p-value. Once you know that, you're pretty much finished. Now, a computer software, blah, 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 right? We're going to use SALT. A multiple choice test consists of 17 questions. 5 choices each. A teacher wants to test a hypothesis that a student is guessing. And we are going to set this up. So the parameter of interest is the probability that he gets a correct answer on each question, right? Is it each answer? Yeah. So we're interested in what's the chance that he gets it. Now, since this question has 5 choices, if you were guessing, wouldn't P be 1/5, which is 0.2? What would the alternate be if you weren't guessing? Suppose you actually knew something. What would your percentage chance of getting it right be? Bigger or less than a 0.2, which is what you get when you guess?
Greater.
Yeah. So P is greater than 0.2. Now, that is where I'm pausing and I'm moving over here to SALT now. So one proportion's good. In this question, what did he end up getting? Did they say? Oh, here we are. The student got 9 out of 17. I'm glad you wrote it that way. So 9 out of 17. And the hypothesis test is 0.2, and it's bigger. So if I generate results, I get a p-value of this fella here. And that's 0.003. Okay. Write a sentence or two interpreting the p-value. The p-value is the probability of you getting 9 out of 17 questions correct if a student is not guessing. Now that's actually the probability that you would get it if you were guessing. Isn't that the p-value? You're guessing. What's the chances that you got 9 out of 17 right? It'd be that fella there. Now this p-value is less than the standard significance level of 0.05. So there is sufficient evidence to conclude that the student was not guessing.
Where are you getting the 0.05?
Every time, every time they say standard for significance, this textbook assumes that that's 0.05.
Okay.
It's what they've decided to call the standard one. It would have been a better question, I think, if they moved the goalposts right, had a couple of 0.1s and a couple of 0.01s, just so you get used to different choices. But I guess they're taking the middle of the road and making it 5%, kind of for everything, which they missed an opportunity there to make the question a little bit more realistic. Okay, now the next question doesn't even have a story, but nonetheless, we can still answer it. We are going to find the p-value for a story where the null hypothesis is it's 0.25, that the alternate is it's bigger than 0.25, and we got this fella. N is the sample size and X is how many people said it. So in this story, 30 people out of 70 got whatever it is correct. And the P0 is 0.25. And the alternate is, oh, it's another greater than, so I can leave that alone. So when I generate the results, can you see that I get a tiny p-value again? And if you round that off to 4 decimal places, I think that turns into a 3. And then it's one of those what's probability things. And then you're doing essentially that guy, right? Or that guy. Well, it's one of those two guys. Are we good with the next one? Right.
What was the answer for that last bit? Sorry.
The answer for here or for this one here?
For B, for the word part.
Okay, I guess I should read it. Write a sentence or two that interprets the p-value you found in part here. So I got this guy. So this is the probability that you got 30 out of 70. There we go. You got 30 out of 70 if P is actually that number. So it's this one here. So the chances that I got 30 out of 70 in the world where this was true is the p-value, which is very unlikely.
Okay, thank you.
Right. That one could have had another bit. Wouldn't you be able to say there's enough evidence that the null hypothesis is true? I should say the alternate. In other words, there's evidence to prove that whatever this thing is measuring is bigger than 25%. This one is about seeds and watermelon seeds. You know, if you keep them if you store them in dark places at least, you can bring them back out and maybe use them the next year or 2 years. And some of them, not all of them, will germinate, right? And if you just leave them out, well, we wouldn't get watermelons. I don't care weather's up for it, but California probably could, right? You could grow the damn things. So that's what this story is about. And they're looking at how many would you expect to sprout. So in this story, this person had 100 seeds, and he kept them in a nice place. And when he went to germinate them, 58 of 100 made it. And does this provide evidence that over half of them made it? So the p-hat is 58 out of 100. So p-hat is 0.58. Now, the null hypothesis is always equal to, in this case, 0.5. And he believes that there's good evidence that it's over half. So that's why I'm choosing the greater one, right? Whatever he thinks there's evidence for is what your alternate should be saying. I think there's evidence that's more than a half. That's what my alternate should be saying. Now, I have enough data to transfer over here. So what do we know? We know it's 58. And we know it is out of 100. And the hypothesis test is 0.5. And he believes that, oh, it's another greater than. So everything is set up. So when I hit this, I should get a Z-score, which is this fella, sometimes called the statistic. And now, if you look at this fella, would you agree that that guy is not less than the standard 0.05? And when it's not less, isn't that not enough evidence to reject the null hypothesis? So one of these should be that.
Is it less than what? Sorry, I didn't.
It should be less than 0.05, whatever
Okay.
the significance level is. And in these stories, the significance level, there we go, is 0.05. So I can tell from this p-value that we don't have enough evidence to reject the null hypothesis. So now I have to figure out which sentence says that. Because the p-value is greater than our alpha, check, we fail to reject the null hypothesis, and we conclude that there is not enough evidence to state that more than half. I think I found it. That sentence seems to cover everything. And we have now finished everything we need to do in B. If you watch the video that I've got online, you can find the beginning part done. So I've covered work on the first half of that. Can you hear my dog barking in the background? You know, he's telling us it's a leaf just fell down again. It's a crazy dog, but we love him to death. So I'm now going to go hunting.
The leaves are on attack.
Well, yeah, they're trying to invade our house. You know, they are encroaching on our valuable space or something. Well, you won't believe what he does when he sees a squirrel. Poor little fella goes into shock. Oh, he just came in. Bailey, you coming? Want to say hi? No? What's wrong? Okay, come here. Oh, no. Just have a little break here. Here is Bailey.
Aww.
Yes, he's a big suck up. Come on, is that not one cute dog or what?
What's her breed?
He, little
Oh.
fella,
Sorry.
he's very offended by you calling him the wrong whatever pronoun. Although I don't think dogs know what pronouns are. He's a West Highland Terrier, and he is our fur baby. This little fella is spoiled.
Yeah, he's not moving at all. He's like, this is fine.
Yeah, I could keep teaching like this. Why don't you just do that? No, I'm sorry, I can't. But he's not been getting
What's
Let's
his name?
watch it. Bailey, like in Bailey's
Bailey.
Irish Cream.
Oh,
He's not been getting that much attention because we've not really been up to it. But I'm going to have to put you down. Oh, he doesn't like him put down. I know. Whoops, easy. There you go. Well, I'm glad I did that before we get started. So let's move over to our screen and we'll see. We'll try and cover some of the stuff that we haven't covered from A. So this is me now in single proportion part A hypothesis testing. And of course, I've got all these. It does that automatically, I think. You know, it seems to do it every time I do it. Let's get these guys out. Oh, no, I got lucky there. Let me try something. Oh, good, that works. I found a compromise. I can do that, and then I can kick back in when I need to. So, oh, I should have realized that there's something that I need to tell you before we even go look in there. Where is it? Some of the questions, most of the questions are just finding things like the p-value or the z-score, or the usual kind of numbers that you would calculate in a hypothesis test. And then there's another bunch of questions that are to do with things like errors. There are two types of error in a hypothesis test, and they're called type 1 and type 2. And this is just my description I use for the other class. A type 1 error is when you say there's not enough evidence to, oh God, that's so bad. You can tell my brain's going. I'll read it out loud anyway so I can get my gist of what my brain was trying to say. A type 1 error is when you say there's not enough evidence to say that the alternate hypothesis is true when in fact it is true. So you go and you do your test and you collect your sample and your p-value is like a little bit too big. And so you go and say, look, there's none to see here, right? It's the alternate hypothesis is not true, right? There's nothing to see here when in fact it is true. And that's called a type 1 error, and that's a p-value. And a type 2 error is when you say that the null hypothesis is true when in fact it's not. So you've got two different kinds of error here. One is you reject it when you shouldn't, and the other is you didn't reject it when you should. That's a very short way of saying it. So let me give you an example of how that might work. Suppose that you have a new pregnancy testing kit. And what it does is it tests hormonal levels in women. And if the level is bigger than a certain number, you're pregnant and the thing goes blue, right? And if it's less than that number, you're not pregnant, right? That kind of test. And those tests don't work perfectly, right? Sometimes you're told that you're pregnant and you're not. And sometimes you're told you're not pregnant when you are. Those are actually the type 1 and the type 2 errors. So let's suppose that we set up without numbers. So this is much more in English. And H naught is that you're not pregnant. And the alternate is, how would I phrase that? You are pregnant. So type 1 error would be, you tell a person, right? They are not pregnant. Right? You tell them that's true when they actually are pregnant. And the type 2 error would be you tell them they are pregnant when in fact they are not pregnant. And just check I've got the numbers the right way around. You tell them that they are pregnant, and I did. So I'm glad I had a quick check. If you say that's true, then it's not, it's a type 1 error. If you say this is true and it's not, it's a type 2 error. So maybe that'll help. Right, now both of those are errors, right? Both of those you got it wrong, right? But you got them wrong in different ways. And there is no way that you can do a hypothesis test or a pregnancy testing test that's not going to have those two errors. But if you make one of them small, you're guaranteed to make the other one bigger. See, if you reduce the amount of hormone that you're going to accept before you say pregnant, won't there be a lot of women who are not pregnant who will now test positive, right? But if you switch it the other way around, you'll get fewer of this error, but more of that. So what you need to do if you're in the practical world and you're saying, okay, then, since there are two kinds of error there, and I can't have both of them get smaller at the same time, how do I cope with that? Based on you're not allowed to like change your sample size. Right, Isabel, what's the question?
Just real quick, is this like a false negative, false positive?
False negatives and false positives are another version of type 1 and type 2. So yes, is the short answer.
Okay, so they aren't the same thing?
They are.
Oh, okay, cool.
Right. Now, which one of these two errors do you consider the more serious of the two? Because once you can make that decision, and in some situations, both are equally bad or both don't matter. But I think in this case, there is one error that I would say is more severe than the other.
False negative, because then you go around thinking you don't have something that you do, and it might require action, like quarantining or medicine or something.
Right, and in the world of pregnancy, couldn't it make you say, oh, well, I'm not pregnant, I can go out partying with the girls, and I'm a 40 smoker a day, so I can't get that. But when they're told they're pregnant, you probably had friends that say, well, I'm off the drinking the cigarettes till the baby's born, right? Because we have good evidence that those are bad things that you should be doing when your baby is in development. So if that was the case, and I think it would, wouldn't you want this to be as low as possible? And well, what would be the consequence of telling someone, I've got that the wrong way, but telling someone that they're not pregnant? Let's rephrase that, my brain is gone. Telling someone that they're pregnant when they're in fact not pregnant. I mean, it might worry them a little bit, it might disappoint them when they find out that they're not, but would you agree there's probably not an awful lot of health issues associated with that, but there could be some psychological ones. So if you can make a conscious decision on which type of error that you want to reduce, you can certainly work on that. And the type 1 error is your p-value. And we tend to work on this guy because he's the one we can calculate easily. And we make this guy nice and small. That means we're going to get it right a lot of the time, aren't we? Because if this is small, isn't that the percentage of time you get it wrong? I've been using that term a few times. So let's see what that looks like. Once I find the question I'm trying to get to. Oh God, it can't be that far. Oh, so here it is. Let's see what we have here. Suppose that a woman thinks she might be pregnant, so she takes a pregnancy test. Considering the situation to be analogous to a hypothesis test, so that's basically the question we've been doing a few minutes ago, write each of the following words. The null hypothesis, right? In the story I gave, wasn't the null hypothesis, oh, if I wrote it down here, is that she's not pregnant, right? None to see here, she's just what she was last week. The alternate hypothesis is that she is pregnant. Agreed? Now, what conclusion if there's not enough evidence to reject the null hypothesis? So, if there's not enough evidence to reject the null hypothesis, does the pregnancy test show that she's pregnant, or would we say that the pregnancy test shows she's not pregnant? Right, would you agree? That would be that's what it would look like. It won't be blue, it'll be, I don't know, if it's clear or whatever. I've never dealt with that, but maybe some of you have. Just out of curiosity, I know it's blue because I've seen the adverts, but I have no idea what the colour is if it's not. Does it have a colour if it's not pregnant?
It's usually like 2 lines or a plus sign or
Oh, so it's not even
And then
coloured
like
anymore.
if the second line shows up, it's a positive, and then if like nothing shows up, it's negative. I really wish that they would do like one color for each, because like I've been in rooms where people have been like testing them, and because it doesn't show up, you either wait for something to show up or for nothing to show up, right? You're not waiting for one or the other, so it can be stressful.
I
But
get that.
eventually you just have to kind of determine and be like, okay, I think it's been long enough, it's negative.
They make those. It's called the ones that say pregnant and not pregnant that spell out the
Okay,
word.
well,
Yeah.
there you go.
What, a word
Yeah, the
appears?
digital ones.
Yeah.
Words says pregnant or not pregnant.
So most of you don't know this, so you don't need to say the rabbit died. Very few know the context of that, okay. The conclusion then, if it was rejected, well, if it was rejected, doesn't that mean that she's pregnant? So you can see that we're transferring these. These aren't so much the errors, but aren't they what the null and alternates would mean in the context of this particular story? Now, this question here, which I'm going to have to make bigger because I can hardly read it and my eyesight's not great, is basically a very similar question to part B. There's some big overlap in a lot of questions. So about 10% of the human population is left-handed. Suppose a researcher looks at artists and he thinks that artists are more likely to be left-handed than the general population of 10%. I can understand that. So P is 0.1 nothing. And the alternate is he thinks that artists, and more of them, right? Now it says give the null value. See this number here? I guess I should make them the same number. See this number here? That is called the null value. It's also called P with a little 0. You see me write that down? P with a little 0. That's what that's called. Now, what proportion of the sample is left-handed? Wouldn't you call that P hat if you were doing the question? And in the sample he got is 108 out of 800. So I'm just doing it on my calculator here. It's 108 divided by 800, and I get 0.135, but at least I hope I do. Now, you got all this stuff here about calculating the p-value and so on. Essentially, to calculate the p-value for hypothesis test, what probabilities should the research calculate? And make your answer specific to this. So
Sorry,
the p,
real
yes,
quick, I might have missed it. How did you get the 0.135 for C?
I went and took the sample of 104 out of 800.
Oh, okay.
So if I was trying to calculate the p-value, isn't the p-value the probability that the sample proportion would be same as 0.10 for a sample size of 800? I'm trying to find all the numbers. If the population was actually 0.10, and now I've seen that, I know that this one is the other number. And there are some choices here. It could be at least, at most, but I'm going for same. One of these guys is the Z-score. Now, there are so many versions of what the Z-score is, depending on the context. Didn't we do one that was P hat, take away P naught over the standard error? Haven't we done all sorts of other versions? In this case, we are going to be looking at sample estimate, take away the null value, divided by the standard error. So we're picking that one. And they ask us here, what is the appropriate numerator on this expression? The numerator is that guy there, the top guy. And so if I look at our values, the sample was 0.135, take away 0.10. And so the answer is 0.035. So the numerator of the Z-score, which is this guy, would have been that. And they never gave us any salt button. So that's telling me that none of these calculations do I need to do a salt, right? I can do them all just by hand. Right, the p-value is the probability that the null hypothesis is true. Is that the p-value? No. Isn't the p-value the probability that you get the sample you got if the null hypothesis is true? That might sound like I'm being a lawyer, but that's what it really is. Well, someone earlier mentioned false positive. So here's a little sentence to pick from. A medical insurance company wants to know whether the proportion of customers requiring a hospital stay during a year will decrease if it provides coverage for certain types of alternate medicine. So alternate medicine, chiropractor, right? You go to a chiropractor instead of turning up because your back's locked. Do you do them? They do them more in Britain, I think, than they do in America. Can you go to what I would call, oh, what is the name we call them? Do you know the herbalist person that you go to and they give you pills made out of aniseed and something else? And
It's a natural path.
Naturopath, there you go. So you do have naturopaths, right? Some people believe strongly in them, some people don't. My own opinion is that naturopaths work only because of the placebo effect. So if you think strongly enough that it's going to reduce your headaches or is going to make your appetite not as strong, whatever it is you're trying to take, and you believe it strongly, it probably will have some effect, in my guess. So the null hypothesis is the proportion requiring hospital stay will not increase. So let's just say that that's 10%. We would probably phrase that as P equals 10%, right? And it's decreased as the alternative, right? If the null hypothesis is rejected, then that makes this true. Right? Explain what type error one would be. Well, the type 1 error is that we do that and it's actually wrong. So the type 1 error would be that if the company believes that the portion required hospital stay will decrease, but when in fact it doesn't. That's what that one is. Right. A type 1 error is that you reject the null hypothesis, right? You say there's evidence and there really isn't. And that's what that, to me, that's what that says. Now, in a type 2, wouldn't you actually say there's nothing to see here when in fact it was true? It did reduce, hospital stays. So I now have to figure out which one of these sentences does that. And I believe it's that one. A type 2 error would be made if the company believes that the proportion requiring a hospital stay will not decrease, but in fact it does. You see, you got it wrong that way. Explain which type of error would be more serious for the insurance company. Type 1 error, where you said you thought it decreased the stay, but in fact it didn't, right? People still ended up in hospital the same way they did, right? And the type 2 error is that you thought it made no benefit, right? But in fact it did. Which one of those two do you think would be more serious for the company's profits? I see 2 and I see 1. So all I need to do is hear your evidence for either one. Barbara, would you want to go 1 with?
Oh, I have to talk it out loud. It's so confusing for me.
Right.
So type 1 is when the null hypothesis is actually true.
Right. Well, what you want to do is just use this sentence here.
Yeah.
So the company believes that the people requiring a hospital stay will decrease, but in fact it will not. What would that have? What effect would that have on their profits?
It will not decrease.
Right, because wouldn't they still end up in hospital and you have to pay all the hospital fees? But on top of that, haven't you paid for chiropractors and naturalists and yoga lessons and whatever else you decide is in that second group? And the benefit is you get nothing, right? Now, what would be the problem if you were doing a type 2 then? Well, in the type 2 world, you wouldn't lose any money directly, I guess, because what would you do is you would stop providing yoga lessons and chiropractor and all the other things, right? And people would just be left to go to hospital. So I guess in their way of looking at things, type 1 error causes more money problems to them. Now that's from the company's perspective, but you're a patient, which most of us are, right? Most of us don't own insurance companies. If you're a patient, would you agree the worst one for you is the type 2 error? Where if you had went to a chiropractor or yoga lessons or whatever it is that you're doing, and that stopped you from ending up in hospital, wouldn't that be a benefit to you? Right, you're not going to hospital. You got a cure earlier in the stages, so it's likely to increase the company's. The company would not be making or would be making additional payments. And for the customers, we've decided it's 2, and then you fill in the sentences. Okay, here we have well, yeah, we've got time. Here we're looking at medical research, and I believe there may be a link between baldness and heart attacks in men. I'm not convinced by that, but maybe they found some evidence. I think it's probably going to be, if they do find evidence, it's probably going to be one of those lurking variables, isn't it? Bald people tend to be older than non-bald people. And don't old people tend to get heart attacks more often than young people? So you might be conflating the two together and thinking that baldness, because if you did believe that, wouldn't you be getting people to get hair transplants and giving them stuff that you put in your head and rub to make your hair grow, right? Because that would be the cure if hair was affecting your heart health. Okay, so state the null and alternate for this particular relationship. So the null is there's no relationship between the two, and there is a relationship between the two. Right, that looks good. So that's the one I'm picking. The null hypothesis is nothing to see here, right? No relationship between the two. So that's why I'm picking that one instead of the one underneath. Now, a type 1 error would be that you said, I have evidence that that's true, that bald people have more heart attacks than people who are not as bald. So one of these 4 sentences would represent that. Right? So a type 1 error would occur if I decided there is a relationship between these, when in reality there is not. Oh, good, I got it the first time. Now, a type 2 error, as unlikely as it could be, wouldn't a type 2 error be that I didn't reject the null when I should have? In other words, baldness does affect your heart, right? I have no idea what that causal effect could be, but let's say it's true. But I've rejected that out of hand. So a type 2 error would occur if you decided, let's say, there is not enough evidence to conclude there is a relationship, when in reality there is one. So that would be that one. I'm getting really tired here, I apologise. So if I've made any mistakes at the earlier, I guess you'll find out because isn't there 5 guesses? So if it's not the first one, you know it's going to be the second one. So when I've done that, will you read the right answer and say, okay, that's why they picked that? Hopefully that'll make sense. A politician is trying to decide whether to vote for a new tax bill. Well, that's kind of relevant. Happening right now. That calls for a substantial reform. A random sample of voters in his district led him to believe that this alternate was true. In other words, more than 50%, right? The majority of people who would vote for him think that this is a good bill, right? As a consequence of this, he decides to vote for that bill. Would you be surprised that many politicians don't have independent thoughts on what they believe to be true? Would you agree a lot of successful politicians, don't they tend to go the way the wind blows? So if they can get a lot of votes being in favour of something or being against something, it's not a surprise that they tend to be in favour or against whatever it is I'm talking about, right? I got my little dig at the politicians in. What error types occurs if a politician believes that more than half the voters support that tax bill when it's really not that number? Is that a type 1 or a type 2? So what are we looking at here? Aren't we looking at he's accepting the alternate hypothesis and it wasn't true? And when you accept the alternate
Type 1.
it's a type 1. If you accept the alternate and it's not true, it's type 1. If you accept the null when it's not true, it's type 2. It's a kind of wrong place, right? When you take the top one and you shouldn't, it's a type 2. When you take the bottom one and you shouldn't, it's a type 1. You try and think of 2 and 1 back to front, might help. Now, what error occurs when the politician believes that the proportion of voters is not a majority and the consequence is that he doesn't vote? Well, wouldn't we call that one the other error, right? The type 2. Now, which one of those 2 errors would a politician consider the more serious, right? He voted for something and it ended up that the majority of his support were against it. That would cause problems, wouldn't it? Wouldn't he probably lose some votes, right? Now, the opposite of that is that he votes against it when a lot of them were in favour of it. I'm trying to think which one of those 2 would make a difference. I think it's because it's a substantial change. Wouldn't that be, you got it wrong really badly? And so it's probably safer just to be in the fence. So that's a good look at picking that one. Oh, we got the pregnant women one. Well, we've already done that question, haven't we? And that's just the way they phrased it. A new drug to help battle anxiety has been developed, and it claims that only 11% of its patients have shown some side effect. An independent lab plans to test this new drug, and it believes more patients will experience some kind of side effect than they said. So won't the null hypothesis be as its equal? And they believe it's bigger. Well, my brain's still looking at. Have you ever noticed drug adverts are scary? Right. There's a new drug out, I can't remember its name, and I'm probably making half of it up because I've been on various medications in the last few days. But let's say there's a new treatment for asthma, right? You take this treatment and it reduces your asthma. I think it was an asthma advert, and I was thinking, oh, that sounds kind of interesting because I have asthma. And right now, breathing isn't my favorite thing to do because it hurts my chest. I might be interested in that. And then right at the end, don't they give you a list of all the horrible things that happened to you or could happen to you? And they involve things like kidney failure, sudden death, brain hemorrhage, you know, they went like a list of 40, well, I'm exaggerating, but you know, like 14 things. Nausea, not a biggie, right? Reduction in blood pressure, and they went through this list. And after it, I went and thought to myself, yeah, I don't think I really want that drug anymore. And excuse me. Unfortunately, if I was being scientific about it, wouldn't it be nice to know what percentage of people got any of those side effects? Because if it was 1 in a million, I might risk it, because would you agree, breathing better and not dying because you have an asthma attack in the middle of having flu and congestion and everything else, probably it would be worth a risk. And if it's a 1%, you know, side effects, then I probably wouldn't. I think they cover themselves because of litigation. Don't they get sued? So if they put in their advert, this may cause, you know, blood hemorrhaging of the lungs, then if it does end up that that's what happened to you, can't they say, well, we warned you, so you can't sue us? So, but to finish with that, I would love them to put the percentage in the samples, right, of all the people who's taking that pill, you know, what percentage actually got each of those particular side effects. Wouldn't that be a useful thing to know? So you could make an intelligent guess on what medication you might or might not choose for your illness. Okay, moving on to 24, got my little gripe gone. Oh, I got to get another one gone. Did you know that the new thing that they're going to pass is going to cost us nothing? The politicians. Did you hear that? Yeah, the new, I don't know what it's called. Is it called Build Back Better or something? Whatever it's called. Or infrastructure bill. I can never remember what they're called. Anyway, it's going to cost us nothing. And I was amazed at that. And I was thinking, if that is true, why don't they do whatever it is they're going to do, but do it 10 times more? Because isn't 10 times nothing still nothing? And then my brain says, but that doesn't make sense. And so I come to the conclusion that it doesn't cost nothing. And then I came to the conclusion, who's dumb enough to believe that it costs nothing? And evidently, there must be a lot of people. Go figure. Now, since I'm not allowed to vote, I can slag all politicians. I have no idea where we are. Are we looking at 24 here? Okay, we've only got a few guys to go, and I think we're going to be perfect timing as well. A botanist for a large rose farm told the management team that 16% of the roses get insect damaged, which means you can't really sell them because who wants roses with bits chewed out of them, right? Based upon the current sales data, the management team thinks that the proportion of roses damaged by insects might actually be worse than that, because, right, people, nah, I'm not buying them, and they send them back, right? So we know that the null hypothesis is this. Based on the fact that they believe that it might even be worse than that, would you agree this is a one-sided test? Which one of these 4 choices would fit the storyline described in 24? Is the alternate this guy, this guy, this guy, or this guy? And we think it's worse, don't we? And if you're worse, isn't it? Oops, can't click on it. Would you agree it's the 4th one? Here's another quick story. Nationwide, it's estimated that approximately 13% of adults smoke. Suppose you believe that that is actually, where you live at least, different. Different is important. It doesn't say more, doesn't say less, it says different. So won't the null hypothesis be that it is equal to 13, which it always should be? And which one of these is going to be the alternate for being different from that number?
Not equal to.
Agreed. You see, these questions for homework are going to be pretty quick. Would you agree? Now, identify the appropriate type of test to be carried out there. Do we call this test a one-sided or a two-sided? It's a two-sided. If it's a greater than or a less than, don't we call it a one-sided? And I can't see of any situation where that one there is even a choice. Question 26 then. DNA testing is not 100% accurate. And we're talking about, you know, when you put in your DNA and you do heritage.com, right? And it tells you you're 80% French or something, that kind of thing. We're not talking about they get some saliva in a murder scene and it's George Smith's DNA, right? That kind of DNA is really, really accurate. And don't quote me on this number, but I'm pretty sure it's true. The chances that you have the same DNA as anybody else in the world is about 14 billion to 1. Right? It ain't going to happen. Twins, even twins don't have the same DNA, right? There is a difference between them. Have you noticed that some twins, and I'm talking about duplicates, right? Still have differences, right? The genes that you got were slightly modified differently in the womb and from your other brother or sister was. Right, back to this one. Suppose a company that manufactures home DNA testing claims that they're 90% accurate. I've got a feeling this is DNA testing for testing who the father is, right? Based on what I'm reading here. And it's 91% accurate. Okay. So you supply DNA of the baby, you supply DNA of the possible father, and they come back and they're 91% right. Well, not great. Null hypothesis, less than 91. An independent lab believes that this reliability rate is less. Do you see why we chose that less than 1, right? Now, isn't a type 1 error then? You say this, right? When in fact, it's not true. So you say it's less than 91 when it's in fact is 91. So let's see which one that works for. It's included this is 91 when in fact it's greater than, and it's less than 91 when in fact it's not. Because this is less than 91 in fact, there it is. That's the one that makes that one up. And our last question. How am I doing for time? Perfect, good. Okay, a lot of reading in this one, but probably not an awful lot to type because you notice it's pick 1, 2, 3, 4 again. The article Boston Scientific Stent Study Flawed. God, what a title. Describes a research study conducted by Boston Scientific Corporation. Boston Scientific developed a new heart stent used to treat arteries blocked by heart disease. I think a heart stent is a thing you stick in the vein and it kind of gets bigger. And it allows blood to go through. Okay. Now I've lost the place. Okay. The new stent is called Liberty. Was made of thinner metal. Oh, I didn't know they were metal. I thought they were just kind of hard plastic. Anybody in the medical field, is that true? These things are metal? Anybody know? Are stents metal?
They have different kinds.
Are some metal and some are not?
Yeah, they have ones that are like balloons that will blow up, and that's not metal, but they have metal ones too.
Is the metal just because there's so much pressure and they last forever? Is that why they chose metal?
I don't know.
Okay. So this new one is made of a thinner metal, okay, than the normal ones that are being used. Using a stent called the Express that is also used by Boston Scientific because the new stent is made of a thinner metal. The manufacturer thought it would be easier for doctors to direct through a patient's arteries. Okay, so it's thinner, it's easier to stick in the artery, right? I guess that's the bottom line after all that reading. Okay. One type of problem that can sometimes occur when you put a stent into place is that the artery can become blocked again. So you fix the blockage, but 2 inches later, a different blockage starts, right? It just kind of shoves the gunk further down, the artery. Okay, I can imagine that happening. In order to obtain approval for the manufacture of this new one, the Food FDA requires that Boston Scientific provide evidence that the proportion of patients who get the new one will experience a reblocking less than 0.1. And now we're getting to the nitty-gritty. And this proportion, 0.1, was determined by the FDA by looking at what the stents of today do, right? So evidently the stents of today are about 10% recurring blockage, right? So if you get one, you're great 90% of the time, but 10% of the time in a year from now, you're going to have to go in and get another one because you've got a new blockage somewhere else. So the null hypothesis is for these guys that it's equal to 0.1, and isn't the alternate that they at least did that good, so less than 0.1. Are you happy about the null and alternate for this story? Suppose a hypothesis test for one proportion is carried out based on this sample, and the p-value is this, and the significance level is that. In this situation, if the conclusion is wrong, you are looking at type 1 error. Which of the following is a consequence of doing a type 2 error? Now, if you were doing a type 2 error, wouldn't you come to the conclusion that it wasn't less than 0.1? Right? You would say it's just as good. Oh, you've got a stent that actually does a good job, but you didn't get evidence to prove that it did a good job. So wouldn't that stent never get used? So wouldn't the consequence be that you don't use something that could be of beneficial help to people? Right. So one of those sentences at the end should be something along that lines. I'm not even sure which of those ones it is, but I've kind of reached the end of my tether, so there's 4 there. One of them's definitely right. We'll figure it out later. Say your last name. As I said at the beginning, but you may have come in a little bit late. I am going to be sending out a letter telling you the details of what's going to be in your test 3, and that's on Monday. And to reiterate, Tuesday is just going to be watching a lesson like this that I'll put online sometime later on that Tuesday. And there won't be any homework on that particular week.
We don't have class on Tuesday. We only have class.
Oh, you don't? Well, I will still be putting one up on Tuesday because my other classes got it. So you get to see what they would have seen. Because we've missed part 2 and I want part 2 to be done.
Wait,
right?
so when will we know what's on the test?
I will tell, well, you can tell what's on it. It's going to be some of, because there's too much to include, from everything you've done from 6, 7, 8, and 9, right? The last 3 weeks. Right, so I could,
Okay.
right. Once I get my head together and I can think more straight, I'll send out the little learn that'll give you a list of the topics and you'll know.
Okay, and the test is on Monday?
On Monday, usual place, usual time, usual everything. It's on WebAssign. You've done 2 tests before. This one won't look any different. Right, you do your work in and you show me on paper any questions that you can show me working for. You get the extra credit in case it's wrong.